Okay, we are up to section T5C, Electronic Principles, Capacitance and Inductance, Impedance, RF, and Power Calculations. There are 13 questions in this pool, and one of those will be on your exam. What describes the ability to store energy in an electric field? D. Capacitance. Capacitance is the ability to store energy in an electric field. A capacitor stores energy between two conductive plates separated by an insulator or a dielectric. What is the unit of capacitance? A. Farad. The farad is the unit of capacitance named after physicist Michael Faraday. The ohm measures resistance, the volt measures voltage, and the Henry measures inductance. What describes the ability to store energy in a magnetic field? D. Inductance. Inductance describes the ability to store energy in a magnetic field. An inductor or a coil of wire creates a magnetic field when current flows through it, and that field stores energy. What is the unit of inductance? C. Henry. The Henry is the unit of inductance named after American scientist Joseph Henry. Don't confuse with farad or capacitance or ohm or resistance. What is the unit of impedance? D. Ohm. Impedance is measured in ohms, the same unit used for resistance. Impedance is the total opposition to AC current flow, which includes both resistance and reactance. What does the abbreviation RF mean? A. Radio frequency signals of all types. RF stands for radio frequency and refers to radio frequency signals of all types. This encompasses the entire range of frequencies used for radio communications. What is the abbreviation for megahertz? It's B. MHz, capital M, capital H, lowercase z. MHz is the correct abbreviation for megahertz. The capital M stands for mega or million, and the HZ is the standard abbreviation for hertz. Capitalization matters in metric prefixes. What is the formula used to calculate electrical power, or P, in a DC circuit? The answer is B. P equals E times I. Power equals voltage times current. P equals E times I, measured in watts, where 1 watt equals 1 volt times 1 amp. How much power is delivered by a voltage of 13.8 volts DC and a current of 10 amperes? A. 138 watts. Using P equals E times I, P equals 13.8 volts times 10 amps equals 138 watts. 13.8 volts is common power supply voltage for amateur radio equipment. How much power is delivered by a voltage of 12 volts DC and a current of 2.5 amperes? B. 30 watts. Using P equals E times I, P equals 12 volts times 2.5 amps equals 30 watts. How much current is required to deliver 120 watts at a voltage of 12 volts DC? B. 10 amperes. Using I equals P divided by E, I equals 120 watts divided by 12 volts equals 10 amps. This rearrangement of P equals E times I is useful for sizing power supplies and fuses. What is impedance? B. The opposition to AC current flow. Impedance is the opposition to alternating current or AC current flow in a circuit. It combines resistance and reactance from capacitors and inductors and is measured in ohms. What is the abbreviation for kilohertz? B. KHZ, lowercase k, capital H, lowercase z. KHZ is the correct abbreviation. Lowercase k is for kilo or thousand, uppercase H is for hertz, and lowercase z. Metric prefix capitalization follows strict rules. So here's some of the key takeaways for electronic principle essentials. MICE is a mnemonic that you can use, magnetic field, inductance, capacitors, electric field, both store energy in different types of fields. The power formula is P equals E times I. Rearranged, it's I equals P divided by E, and E equals P divided by I. This is your second essential formula alongside Ohm's law. Impedance is the opposition to AC current flow and is measured in ohms, and it combines resistance and reactance from capacitors and inductors. RF means radio frequency signals of all types. Common abbreviations: KHZ kilohertz, MHZ megahertz, GHZ for gigahertz. And 13.8 volts is the standard ham radio power supply voltage. Know how to calculate power at this voltage using P equals E times I.